Hello, this is Mrs. Huntley. This is lesson 12 of module 7. You're in the supplementary material packet on page 21. And your essential question for this lesson is, how can I compare and order real numbers? So, you've been comparing and ordering real numbers since you were in kindergarten. It's just now we are looking at numbers that are more complex, and we have to make sure, number one, that all the numbers are in the same form. So if you're trying to compare decimals and fractions and square roots and other types of radicals, they need to be in a common form. It's almost impossible to try to order something that's not in the same form. So we need to convert everything, whether it's all to fractions or all to decimals, but all of our numbers need to be in the same form. Second, easy, you put them in order. So I was actually not going to record a lesson for this particular part of our module. However, I found out how many people were going to be absent tomorrow because of field trips and everything. So I felt I needed to put something, especially for those students that are not going to be here, so that they have some direction and some way of trying to catch up and be on the same page with the rest of us. So let's go ahead and flip. You're on page 22 now. And what are our tools to compare something? So the first one, I know you guys are used to making like the alligator things. That we shouldn't do that anymore. We're going into high school, so we should be able to use the math words. And when we read from left to right, we read our math from left to right. So if we are looking at something like this, and I'm just using this as an example, and you don't have to write those in there, but we would say 0 is less than 1 because the point is pointing toward the number that is smaller, and when it's on the left, we're going to say less than. Oops, I can write, just not well. So this one is less than, and of course that the next one would be greater than. This one is less than or equal to. And this one would be greater than or equal to. Okay, so how do we order things? Values can be ordered from least to greatest or greatest to least. List some other keywords or phrases that could be used below. So when they're describing something from least to greatest, they could say ascending. Oh, A-S-C, sorry. Ascending. Increasing, increasing order. Or minimum to maximum order. I'm sure there are others that I'm not thinking of right now. So if you want to think of others and bring them to class tomorrow to share with your classmates, that'd be great. But these are synonyms for ordering from least to greatest. Same thing, synonyms for greatest to least, we could say descending. We could say decreasing. Or max to minimum. Again, I'm sure there are others, just not that I was thinking of, and since we are not all together to have an actual discussion about them, think of as many as you can, bring them to class tomorrow, and we'll finish filling this out with other ideas. Okay, so comparing your order, it's helpful to represent the values in the same form. Not only helpful, but pretty necessary. So practice converting between the three forms of numbers below, fractions, decimals, and percents. So if you guys remember from when we were converting our fractions, we could do long division, and our numerator goes inside, our denominator goes outside. So 3 can't go into 1, so where there's a 0, we're going to add our decimal. 3 goes into 10. 3 times, that would be 9, and we have 1 left over. So we know that 3 is going to be repeating. So this one is 0.3 repeating. When you're changing into a percent, you're taking your decimal and you are multiplying it by 100. When you multiply it by 100, that means the decimal is hopping 2 places to the right. There's your 10, there's your 100. Remember, 0.3 repeating means you've got 33333 going on. So this would be 33.3%. Okay? Converting our decimals into fractions. How do we say this properly? It's going to the tenths place. So this would be 2/10. I can reduce that to 1/5. So this part would be 1/5. Again, changing it into a percent. I've got 0.2. Here's my 10. There's my 100. So it would be 20%. Go ahead and fill out the rest of this chart and then come back and check your answers. So pause the video here and fill out the rest of this chart. Obviously here, 50%, you're going to do your decimal and your fraction. Same thing with the rest of these. Okay, so check your answers. We were right here when we left off, 50%. Hopefully you guys know this one off the top of your head, but if you come to one that you don't know off the top of your head, you can write it down and your decimal is here and you're going to hop it backward. So this would be 0.5. And of course, 0.5 is 1/2. 2/3. If you divide 2 by 3, you're going to get 0.6 repeating, which would be 66.6%. 0.75, 3/4, guys, 3/4, which is 75%. 12.5%, again, you're hopping your decimal backwards, so that would be 0.125. Converting that into a fraction, it would be 125 over 1,000 and then reduce from there if you don't know it off the top of your head. 2/5 is 0.4, 40%. 1.5, you remember you're hopping your decimal, so it's not going to be 15%, it would be 150%. Looking at that as a fraction, it would be 1.5 or 3/2. Either one I would take as being correct. And it depends on what you're comparing, whether you'd want it as a 1.5 or a 3/2. So let's go ahead and move on to the next page. Okay, so it's saying compare the following values by placing the correct inequality sign in the box. Now our inequalities are greater than or less than. Now a couple of things to be aware of. First of all, we've got some negative signs here. When you're ordering negatives, remember if you're looking for the smallest one, it's going to be the greater absolute value number. So let's take a look at this. Let's get rid of that so that we can do this. And let's get it into the same form, because we definitely have to have it in the same form. I am going to convert 7/8 into a decimal and compare it that way. So if I'm comparing that, I need some workspace up here, and that's 7 divided by 8. It's not going to go in, so I've got a 0 and a decimal. How many times does 8 go into 70? That's going to be 8, which is 64. And 70 minus 64 is going to be 6. Here. And that's going to be 60. How many times does 8 go into 60? It's not going to be 64. That's too much, so I know it's going to be 7. So I'm actually going to stop right here. I've got enough information because I know that this decimal equivalent, even though I'm not done with it yet, is going to be a negative 0.87. And this one is a negative 0.5, and it's going to go on. And this one is a 0.5. So which one is a smaller number? Again, it's going to be the greater absolute value. This one is more negative. So I'm going to use a less than sign. 7/8 or negative 7/8 is less than negative 5/10. The next one, pi squared. So that's pi times pi, or the square root of 50. Now the square root of 50 is not a perfect square. Let's do, square root of 50 is not a perfect square. It's between the square root of 49, it's 1 greater than 49, and it's less than the square root of 64. So it's going to be 7 and 1. How did I figure that out in my head? Well, remember, we take our the number we're looking for and we subtract that lower number. So that's 1, and now I've got to take 64 and subtract that lower number, 49. That's going to be 15. So it'd be 7 and 1/15. And pi times pi, or pi squared, so it's 3.14 about times 3.14. So it's going to be multiplication. Sorry, I think I hit pause on accident. I just did the first part of the multiplication. 4 times 4 is 16. You put down the 6, carry the 1. 4 times 1 is 4, plus 1 is 5. Put down the 5. And then 4 times 3 is 12, so you put down the 12. Now I need a 0 placeholder, 3.14, and then 2 0 placeholder. 3 times 4 is 12, put down the 2, carry the 1. 3 times 1 is 3, plus 1 is 4. 3 times 3 is 9, and now I have to add it all together. 6, 9, 5, 8, 9. And I've got 1, 2, 3, 4, 1, 2, 3, 4. So 9.8596 approximately. And this one is approximately 7 and 1/15. Although 1/15 is not in decimal form, I can compare my first numbers out here, and I know 9 is greater than 7, so I can say pi to the second power is greater than the square root of 50. Does it make sense how we're going about doing this? And I know I did the long multiplication here, and a lot of you still do the lattice. I did long division over here, and a lot of you are still on partial sums. So I get that sometimes that's the hang up, is not knowing how to do like the basic math behind it, but hopefully you're getting how to compare the actual numbers. Now here we've got, again, they're negatives, so be careful. We've got negatives, but these are relatively easy to deal with. 3/4 is 75, right, or 0.75. If I change that into a percent, it's going to be 2 to the right, so that'd be 75%, but it's negative. So which one is greater? Which one is less than? So I would actually have my arrow pointing in that direction. 60% or negative 60% is greater than negative 3/4. Okay. The next one, I'm going to draw your attention. 5 plus the square root of 60, or 4 plus the square root of 63. We can order this just by looking at these whole numbers that are out in front. Now, 60 and 63, neither one of them are perfect squares, and they fall between the same two perfect squares, just like, oh, I guess it's not just like. It's going to be less than the perfect square of 64, and it's going to be greater than the square root of 49. So it's going to be 7 and something for both of them, okay? So 7 and some square root of some small number. So 7 plus 5 is going to be greater than 7 plus 4. So I can tell without even finishing this whole problem, because of those numbers out in front, and because these are so close together that they have the same whole number. So this one's 7 and, let's see, 60 minus 49. It's going to be 11. So this will be 11/15, and this will be 7 and 14/15. So if not for that number out in front, this one would actually be larger. The one on the right would actually be larger, but because that number out in front, this is one larger, and 5 plus 7 is 12, where 4 plus 7 is only 11. So that's why this one's working out that way. I need to erase some so that you can see how to do this next part. list the following in descending order. So descending means it's going to start big and get small. Okay, so again, I need to get them in the same format. I'm running tight on time here, so I'm not going to actually model how to do these. These you're going to do on your own, but I just want to make sure that you knew how to do them. Now we already have pi squared. We already squared pi up there, so I can say with authority that this one is going to be about 9.859 something something something. And we have one here that's at 11. So I just have to figure these two guys out here. The square root of 121, that's a perfect square, isn't it? So that one's going to be 12. And the square root of 130, we'd have to figure that out. It's going to be greater than the square root of 121, so it's going to be 12 and something, and less than the square root of 144. So 144 minus 121. 23, and then 130 minus 144. I'm sorry, backward. I got distracted by the intercom right now. So 130, 130 minus 121. Got to borrow, so that's going to be 9. So it'd be 923s. So if I'm putting this in descending order, I need the largest number first. That's going to be the square root of 130. Next is going to be, oops, I did this wrong. This is not 12. I bet you guys were yelling. This one's 11. So next is going to be 11.1. Then the square root of 121. And finally, the last one is going to be pi squared. Just watch the words. Here we've got increasing order. So you're going to start small, get bigger. Ascending, again, that's small to large. Number 8, today's temperature for 4 different towns is shown below. List the town in ascending order. Starting small, getting bigger. And then do the summary and try to work on page, the next page. All right, sorry, went long, but it's still under 20. I'll try to do, well, actually, this is the last lesson in this packet before we are going to be reviewing for the test. And I'll probably create a video of the review, the study guide. So other than that, we're good. Have a great night, and I will see you tomorrow. I hope you enjoyed the field trip if you're on the field trip today.